Alright, so here's our next video at looking at the elimination strategy of solving linear systems. And I've sort of shrunk down and kept our rules from last time, our steps from last time, and how to take care of it. And we're going to keep on going with that today, except we're going to look at a little bit different situation that sometimes pops up with this type of thing. And it pops up when maybe you have something like this. Maybe you have like negative 6x take away 3y is equal to minus 24, and we've got 2x take away y is equal to 24. Okay. So maybe something like this. And you look for a variable with the same coefficient. Well, you might want to jump at the 24s, but that doesn't count because those aren't coefficients; those are constants. The x, you got a 6 and a 2 with the x, you got a 3 and a 1 with the y. We don't have one that they have in common. So what do you do if the first step here? What if this first step here isn't working too well? Okay, well, this is where you have to change things up a little bit. If there is no common coefficient, what you have to do is you have to actually make one. And it's not actually that hard to do. You basically just have to take one of the expressions and you just change it a little bit. So what we're going to do is you can pick whichever one you want. You can pick the x or you can pick the y. It makes no difference. But what you have to do is you have to find the lowest common multiple for one of the variables. So for example, if I look at my x variables, well, I've got 2 and I've got 6. Well, for 2 and 6, the LCM would be 6. They both go into 6. For my y variables, I've got 3 and I've got 1. The LCM for those would be 3. And you can pick either one, it doesn't make any difference. And what you want to do is you want to then change one of the expressions to make it have the same LCM value. And I'll just show what I mean. We'll use this one right here. We'll use this one right here. And I'm going to use the x's. So I've got the 6x here, but I don't have 6x here. So how can I take this and change this into 6x? Well, I can take that entire thing, and I can take that entire expression, and I can times it by 3, which may seem insane, but you can do that as long as you do it to everything. I'm going to multiply the entire expression by 3. So if I do that, this would become 6x. This would become negative 3y. And I also got to times that by 3. If I times that by 3, you get 72. Now I have two expressions that have a common coefficient for a variable. So these are the two expressions that I am going to put together. So I'm going to rewrite them. I've got negative 6x take away 3y is equal to negative 24. And instead of using this one, I'm going to use the purple one. 6x take away 3y is equal to 72. Now I've got a common coefficient and I can put these guys together. So I'm going to take these two and I'm going to add them together. So if I add the 6's together, they cancel out, got nothing. So this would be negative 3y, that's negative 6y, negative 24, and add a 72 to it. That will leave me with 48. Okay. Now I divide by negative 6 on both sides, and y is going to be equal to negative 8. And there's my y value. And then I can take that value and put it back into any of the original expressions. You're probably not going to use the purple one because it's bigger. Probably one of these two right there. And I can solve for my x value. So I can take that and I can put it back into, I'll use the 2x minus y equals 24. I've got 2x take away negative 8 is equal to 24. So 2x plus 8 is equal to 24. So 2x is going to be equal to 16. So x is equal to 8. So my solution for the question would be 8 and negative 8. So there's my negative 8 and there's my 8. Okay, so once you multiply one of the equations, you can multiply whichever one you want as long as you have a common coefficient by using LCM idea. No big deal. It'll all work out and then it works out being the same type of thing. Okay. Okay, so let's get rid of this and let's try another one. Okay, so let's try it with these ones. Let's try negative 2x plus 2y is equal to 20. And we've got negative 4x take away 12y is equal to 24. Okay, so none of my coefficients match up. So I'm going to change one of them. And what I often look at is, can I change the 2 into a 4? Can I change the 2 into a 12? Well, absolutely. If I take this 2, I times by 2, give me 4. If I take the 2, multiply by 6, it'll give me the 12. Okay, so it doesn't matter which ones you match up. I think I'll try and match up the x ones because they give me smaller values. So I'm going to multiply this by, I'm going to multiply that entire expression, I'm going to multiply by 2. So if I multiply that top expression by 2, it's going to be then changed to negative 4x plus 4y is equal to 40. And you could have multiplied by negative 2 as well. It doesn't matter as long as the numbers match up. And then my second expression is going to be the same. All right, so now I've got matching coefficients. All right, so I've got negative 4, so I'm going to subtract them this time to get rid of them. So negative 4 take away negative 4, of course, is 0, so these guys just cancel right out. 4y take away 12y is going to give me 16y. And 40 take away 24 is going to leave me with 16. And then you see y is equal to 1. All right. So now I'll take that value and I'll plug it into one of my original expressions. So I got negative 2x plus 2, 1 equals 20. So negative 2x plus 2 is equal to 20. Negative 2x is equal to 18. So then x is going to be equal to minus 9. So my solution for this one, negative 9 and 1. Negative 9, and there's my 1. Okay, so that's how that one works right there. All right. Okay, so let's try something else. Okay, so let's try this one. Let's try 2x plus 4y. I'll clean that up a little bit. Plus 4y is equal to negative 2, and 7x plus 11y is equal to negative 15. Okay, so let's try this one. All right, so I like to check, can I change the 2 into a 7? Well, not really nicely. Can I change the 4 into an 11? Well, not really nicely, no. Okay, so this is when it's the same idea, but we got to look at it a little bit differently. This is where we got to do the whole LCM thing again, the thing we're talking about here, find the LCM for a variable. And I'm going to use you can use the 4 and the 11, you can use the 2 and the 7. I'm going to use the 2 and the 7. But if I find the LCM for 2 and 7, the smallest number they both go into is 14. Okay, so that's my LCM for 2 and 7. So I'm going to change both of these guys into 14s. So to change the 2 into a 14, I'd have to times everything by 7. To change this one to a 14, I'd have to times it by 2. So sometimes you have to multiply one expression by a number, but if nothing matches up, you end up having to multiply both expressions by a number to make them equal. So I'm going to take my top expression and multiply my top expression, everything by 7. So that's going to turn it to 14x plus 28y equals negative 14. Now I'm going to multiply my bottom expression, everything by 2. So this would be 14x plus 22y is equal to negative 30. All right, now I've got matching coefficients. Perfect. So now what I'm going to do is I'm going to subtract these guys. All right, so I'm going to subtract them to get rid of the x values. So 14 take away 14, 0x. 28y take away 22y leaves me with 6y. Negative 14 take away a negative 30, which actually turns to a plus 30. So negative 14 plus the 30 leaves me with 16. All right, so not a pretty nice little whole number, but that's fine. So I divide by 6 both sides, so then y would be equal to 16 divided by 6, or 8 over 3. Sometimes you just get fractional answers. Okay, and then what we can do is we can go back to one of our original expressions. So 2x plus 4 times 8 over 3 is equal to -2. And now you just solve for x. Now this is going to get a little bit uglier because you got fractions and stuff like that, but it's the same idea. Okay, so sometimes you only have to change one expression, but in this case we had to change both of them. And what you could have done is you could use the 4 and the 11. You could have used 44. The lowest common multiple for 4 and 11 is 44. And you would have times the entire top expression by 11, and you times the bottom one by 4 in order to do that. So you can choose which one, depending on which LCM you see, which one you'd find easier. It's just kind of up to you, but that's how you do it if they don't actually both match up. Okay, all right, so let's try one more question. All right, so let's try 8x take away 16y is equal to -16, and 4x take away 8y is equal to -8. Okay, well, look, actually the numbers are looking pretty good for this one. Can I change the 4 into an 8? Absolutely, really easy. Just got to double it. I could do the same thing with this one, but looks like we just got to double. So I'm going to times this one by 2. So if I times this one by 2, well, I'll write the first expression first. The first expression is going to be 8x take away 16y is equal to -16. Now let's double this guy, which is going to be 8x take away 16y is equal to -16. Okay, well, you may have noticed already that these two expressions are equal to each other. And if these two expressions are equal to, if I try and subtract them to try and cancel off the 8's, I'm going to be left with absolutely nothing. It's going to be 0 is equal to 0 because the two expressions are equal to each other. Well, this is one of those cases where you are going to have an infinite many solutions because these two functions, these two lines are right on top of each other because they're the exact same line, just written differently. You're going to have infinite solutions. Okay, so that happens sometimes. It's the way it is. And of course, if there's no solution, one thing that couldn't be equal to the other, that's when you have like 0 solutions. But this one's infinite. So these two guys will be right on top of each other. Okay, so that's a couple more examples on how to solve using elimination, especially when you have to change one expression to match up the coefficient to another expression, which definitely does happen. And that's where your lowest common multiple stuff kicks in. And sometimes it's really easy. It's got to multiply one expression by a number, but sometimes you got to multiply both expressions to get a common coefficient. Okay, but there's a couple more questions like that.